Welcome back, everybody. We are nearing the end of this glorious semester. We got what? One more lecture, another lecture after this? Let's see. One more lecture after this on Tuesday. So on Tuesday, we covered parabolas. So review of parabolas. (10.1). Recall we had two forms for the general form. We had x minus h squared equals 4p times y minus k. And this opened either up or down, one of these. And we have the other variant was y minus k squared equaled 4p times x minus h. And these either did left or right. Open left or right. In all of them, P was P gave us the distance to the focus. That distance right there was P. Or over there. And in all of them, we had a directrix that was on the other side. Should have just done it right down the middle. Let me go to that one. There we go. That's got it. So let's take a look at let's find the equation for the directrix. If we have a focus at 2, 4 and a vertex at -1, 4. It was a little chilly out this morning. Went outside at like, I don't know, it was 11. I'm like, fuck, I might kind of want to go and get my sweater. So we don't need to overthink this. Let's draw what we know. We have a focus at 2, 4, which is right there. And we have a vertex at -1, 4, right there. Now, without being too particular I do know that the focus is like enwrapped by the parabola, so it should go like that. I don't think it's going to cross the y-axis where I showed it. But this is like just a sketch. I'm not sure where it crosses. I do know it opens to the right to capture F. How do I find the directrix? Anyone remember?
The directrix is the same distance away from the vertex as the focus, except in the opposite direction.
Yeah. So that's how we could find it, right? So this is 1, 2, 3 away. We gotta go 1, 2, 3 away over here. So what do I do with that?
You make a dotted line up and down.
The directrix will be right there. Yes, it's the dot line up and down.
So the directrix is x equals -4.
And it looks like that's where it's crossing, right? 3 left of -1 should give us -4. X equals -4 is that line. What would the equation be here? Let's find the equation of the parabola. Well, we know it's opening left or right, so it's got to be in the form y minus k squared equals 4p times x minus h. And what values do we have of that? We do have an x. What is our x? That's the directrix. X equals -4 is the directrix. No, because it's not on the parabola. Well, we want to fill in what we have, anything we have here, which with already we have. Do we have any of those things? Where is HK located on the parabola? So HK is always the center of our graph. And on our picture for a parabola, it's the vertex. So a vertex of -1, 4 tells me that H equals -1 and K equals 4. Which means I have -H is +1 there. And K is 4, Y minus 4 squared there. Do I have P? Or can I get P? How? Yeah, it's this distance. I think if you go the other way from the vertex to the focus, you'll keep the sign correct. So if I start at the vertex, I go right 3, that's a positive 3. So P is a positive 3. Start at vertex and count steps to focus. So P is positive 3 because it's to the right 3. And that means 4 times P is 4 times 3 is 12. So that is an equation for this line. Any questions about that? All right. Onward. Let's see, let's try another one. Let's say our directrix is at y equals 3. And we have, and where the, let's see, vertex is at, let's say, -2, -1. Let's find the equation on the line of the parabola. And then let's look at the domain and range. Maybe find the focus too. Where is the line y equals -3? Or y equals 3? Is that a vertical or a horizontal line? Horizontal. So we'll go up to y equals 3 and we'll make a horizontal line there. That's my directrix. I got my vertex listed. What does that tell me about my parabola? Yeah, it's going to open downward. It's got to open away from the directrix. The directrix has its back. So yes, it will open downwards. So that's good. I don't know how it's going to do it, but we'll make it indicate that it's doing that. Where could I put the focus? It looks like it's 4 away, right? This is 1, 2, 3, 4 to the directrix. So I can go 1, 2, 3, 4 down. That's my focus. So what is that point? -2, -5, yes. All right. So it's opening up and down. Which equation do I want to use? The x minus h squared one, yes. Up and down is where x is squared. So what should I have? Yep. So what will I have? X minus -2 is correct. So that makes it +2, right? Y minus -1 turns into y plus 1. All right, we're almost there. What is P here? It is -4 because we are going downward to get to it. So P is -4. So this will turn into x plus 2 squared equals -16 times y plus 1. Now I know it's not going to cross the x-axis. It should cross the y-axis though. How could I find where the graph would cross the y-axis? What is the unique property of the y-axis? There's something very special about the y-axis.
It's technically the line x equals 0.
It is technically the line x equals 0. It's the only spot on the whole graph where x equals 0. So if we want to find the y value where that is going to be at, What can I do with that information? We're almost there. I'm gonna drag it out of you guys kicking and screaming. Yep. Let's do that. 0 plus 2 squared equals negative 16 y plus 1. So that's 4. I am not going to distribute the negative 16. I'm just going to divide by it. Let's work smarter rather than harder. And that's when x equals 0. So negative 1 1/4 or negative 5/4. Which is actually pretty close to right there, isn't it? It's pretty close to the same height as the vertex, which means this is opening up pretty goddamn wide. I gotta come over here, and by symmetry, I can put one over there, which means this thing is opening like this, really wide. What's the domain? And what's the range? Yes. Yep. Now what do I put around these?
The side, it's
Excellent. You guys are gonna do well in this upcoming exam.
So you made the point that the Directrix is used because if you go from the focus to the parabola, it's the same distance from that point to the Directrix, right?
Yeah, so like anywhere on the parabola, assuming I've done the parabola, great. Anywhere on the parabola, if I measure this distance d and I do a perpendicular line to the Directrix, that should also be d.
So using that, I made the Directrix like the top of a square, and so I found the points on the parabola of 5, -5, and -8, 5.
5, -5 is way over. That might be on there. Okay. Wait, 5, -5 would be.
It'd be level with the
Does it
focus.
fit? Does it fit? 5 would give me 49 here. -5 is, that makes that -4. -4 times -16, 64. Those don't work.
Well, okay. So P equals 4, right?
Equals -4.
Oh, -4. But so the distance from the vertex to the Directrix is 4, and the distance from the vertex to the focus is 4.
Yes.
So
So if you went over to 5, -5, that is directly this way, 7 steps.
So, oh, okay. Never mind. I realized I wrote down the wrong.
And if that was on the parabola, 7 steps would put the directrix at 2. And
Sorry,
it's not.
x should be 6 in that case.
So there.
Yeah.
So it goes over 8. And that would put it up 8, yes.
There you go. Okay, there you go. I put the wrong number.
Yeah, that is one way to do it. So let's expand on that because I don't know that everyone understood what you're saying. Let's pencil this in a little bit better. Because we can get some learning out of this that was above and beyond what was originally made up. Like I totally made this shit up. But we got our directrix up here. And so that's my directrix. My focus was, or my vertex is right here, -2, -1. I know it crossed at -1, or 0, -1 1/4, which means by symmetry, I have a point there. My focus was at, let's see, let's get this lined up right. That's F. And so we had this part right here. And to get a little bit back, we got that much. And then what Christopher's saying is he used the fact that the distance from the line to the focus and the distance from the line to the directrix at any given point has to be the same. So he said, let's just go sideways. So if I go sideways, how far sideways do I got to go to hit the parabola? So how far sideways? Well, this line right here is the y equals -5 line. Which means the line is going to be wherever it crosses this line right here, our parabola is going to have a y value of 5. So 5 is going to be on there, and he knows that this up here has a y value of 3. This should say -5. So he knows that that distance is 8. The vertical distance from this point is 8. So he said, okay, if it's got to be 8 from there, I need it to be 8 from here as well. So he went and said, okay, let's go right 8. 1, 2, 3, 4, 5, 6, 7, 8. And put a point there. Assuming I did that well, and I'm going to rotate it so I can kind of connect this a little bit better. And we should have one that's 8 to the left as well. And now this distance, he made basically a box. He's got this box here. And we went 8 that way, 8 down, and 8 that way. So that's how we found another point on the line. Is that what you're saying, Chris? Is that what you did?
Exactly.
So he said, let's make a box. And it was all based on this distance right here. He knew this distance here was 8. So I need the rest of the box to be 8. So I need to have an 8 here, and I need to have an 8 here. There's got to be a square. Oh no, I guess it doesn't. He chose it. Yeah, he went from the focus. So coming over here, he knows this distance has to be the same as that distance. Which means this distance has to be the same. That's the important part that matches. This line right here always matches that line right there. So if it were right here, it would be like that, and it'd be like that, and maybe that's D2. It's kind of neat. It doesn't really. I mean, that's the first time I've seen someone use that fact to help sketch it, but it is kind of a nice way to sketch it. It is a way to find other points. I like it. Let's see. What else do you guys want to talk about here? Let's take a look at where this shows up in a real life situation. The Parkes Radio Telescope. Is a parabolic dish. With a diameter of 210 feet. And depth of 32 feet. So it looks kind of like this. There is a little radio tower holding this up. This is the transceiver or receiver. And so this is like held on by like a grate or some shit like that. And that's our dish. I don't know what the bottom of the dish looks like. This probably should be rounded, but I didn't do that. So the fun fact, I was telling you guys the headlights, if the headlight does this, when light from the headlight goes and hits the dish and will bounce straight off. And it doesn't really matter what angle you do it at, it bounces straight off. This also works with shit coming in. Stuff coming in from a distance, like your fucking radio doing the galaxy, shit like that. Stuff coming in bounces and hits the focus. So you can collect radio waves all at a single point and go, okay, what the hell are we listening to? So that's what this is going on. So, and it's telling us that this dish is 210 feet wide, going that way, and that this part right here is 32 feet. So, can we come up with an equation? Let's find an equation putting the vertex at 0 at the origin. So I'm going to draw some coordinate system. And there's no way this is going to be to scale because 32 and 210, fuck all that. But I can try to make it look right. At least have the right shape. Let's call that our dish. Do I know can I figure out the X and Y values for this point and this point? given the information I have. It says the Parkes radio telescope is a parabolic dish with a diameter of 210 feet. What can I do with that? Can I figure out? So 210 is telling us what on this picture? What does diameter mean? For dish? It's the. If you look at it in like 3D, it's making a cup. So what is like, what's diameter mean for a circle? It's related, but like the hand gesture you're doing doesn't match with what it is. What's diameter on a circle? Across.
Yeah.
Across. You're doing the circumference. You're making the gesture for circumference. So diameter is across. So if this is making like a 3D dish like that, the diameter is the distance across. So it's telling me that this measurement right here, going from here to here, is 210 feet. Can I use that to get my x values at these points right here and here? Yes, I can. How?
Would it be like half of 210?
Yes. We have the dishes sitting right in the middle. The vertex is right in the middle, which means it's not lopsided, which means half of it's got to be over here and half of it's got to be over here. So what's half of 210? 105. So this is at 105 and this is at negative 105. Now what? The rest of the sentence says a depth of 32 feet. That's like how deep the dish is. Which means it's talking about this distance right there. So what does that tell me about the y values? If they're 32, that's right. So if we were to keep drawing this parabola, it would be a parabola opening up, right? Which means this is going to be the x squared version. And I know HK is what here? Zero, zero. So this is really x squared equals 4py. I don't know where the focus is on this graph though. So how can I find the focus? Which will give me P basically. How do I find P here?
We have the point where x equals 105 and y equals 32.
And what can we do with that point? That's right here.
We can plug them into the equation and then solve for p.
Exactly. if we plug them in, we have this. Which means P is 105 squared over 4 times 32 is that 128? What is 105 squared?
Uh,
That
yeah.
over 128. So what is that about? Let's round that. Let's use an approximation. That's not really helpful. How far is that? Like what's 11,025 divided by 128? If someone has got a calculator. Let's go like 1 decimal place. That should be good. 86.1. Okay. Which means we got x squared equals 86.1 y. Bam.
Don't we need to times the P by 4?
You're right. I got all excited. That is not correct. All right, what is that times 4? Let's see, we got 320 and 24.4 is 344.4. I think I'm doing that in my head. There we go. Where's the Directrix at? And where's the focus?
It could be 32. So like opposite way. Like down 32.
We don't want to go from the dish. We want to go from where the focus is.
Oh,
Believe it or not, the focus is not on that flat part of the dish. Like if you see right here, it's above it. Where is the focus? So what piece of information gives us the focus? How far away is the focus from the vertex?
32.
No. Ignoring the parabola that we have here, how far away is the focus from the vertex? Ignoring this problem. In general. Anybody?
The vertex is, in this case, because there's no h or k, it's at 0, x equals 0, and y equals p.
Y equals P. The focus is a distance P. That's where I was going. So the focus is a distance P up. So F is up here, which means the X component is 0. The Y component is P, which is 86.1. What does that tell us about the directrix? It goes down to 86.1, right? And what kind of line is it? It's a horizontal line. How do we write horizontal lines in terms of mathematics? Yes. And so what is the value here? Yes. Excellent. All right, it's 3 o'clock. We'll pause that there. That was, I think, a productive hour. Brag it out of you guys kicking and screaming, but we did it, didn't we? We got it done.